Hey guys, welcome back to the Engine Room. My name is Dex, I'm a data engineer, and what I'm teaching in this series is data engineering. Let's do a side quest. If you play role-playing games, you already know what a side quest is. It's a mission separate from the main objective, but taking place in the same world. It's often used to gather equipment and experience points and level up. So what is the purpose of this side quest? Well, if you watched the previous videos in the series, you know that our main mission is to build an ETL pipeline that's going to extract records from a flat file, transform them according to a rule set we specify, and load those records into a target data store. So what do we have so far? Well, we've got our source data, right? Pipe delimited CSV file. We have a rule set that we've specified in the initialization file for xfile. There's still a blank to fill in. We still have to populate the logic for this lookup, but overall what we have kind of works. So if we run that transform, CSV, there we go, and we run that, right? We successfully transform the records. So what we have works, but it works based on a fragile assumption, namely that our input data set is clean. So if I have put together some dirty data, right? The first three records in this file are what we've been working with. The last three records all have one thing or another wrong with them. Okay, they are non-compliant records. And if we run that same transform against that file, it crashes. Okay, that's a problem. We need to try to avoid situations where bad inputs will crash our pipeline, because bad inputs come with the territory, right? Data engineers are kind of like the smoke jumpers of the software industry, except whereas those guys parachute into forest fires for a living, we tend to parachute into dumpster fires for a living, okay? We start out at a disadvantage, and what we have to even the odds is training, equipment, and speed. So on this side quest, we're going to armor up. We're going to build some equipment to help bulletproof or fireproof our data pipeline. So let's write a tool. I want to call this tool filter. Filter with two F's, ffilter, or file filter. Okay, I have some boilerplate code, just like a skeleton for command line utilities, because I write a lot of command line utilities. So we'll populate that, and we'll get down to it. Okay, so here's that filter. Okay, so I use, the first thing is I use docopt a lot. Right, docopt is a Python library that helps you write command line utilities and parse user inputs to your program, command line arguments to your program. The Python standard is argparse, but docopt definitely takes it to another level, and it's a really great tool. I'll put a link in the description. So first things first, and then I'll walk through and then explain it a little bit. So I want I want this utility to read a source CSV file, each of whose records may or may not be compliant, and I want it to emit a CSV file, all of whose records are compliant. Okay, and I know already that I want it to emit the bad records either to a file or to standard out, so we could swap the outputs, right? Either the good records go to a file, the bad records go to a file. So I'm going to say And then I'm going to say source. All right. Okay, so I want to do that, and then I want to do the same thing, but okay. So we may add some more usage strings later, but this is a good start, right? So you run ffilter, you tell it either to send the good records to a file, okay, and in which case it will emit the bad records to standard out, or you can tell it to emit the bad records to a file, in which case the good records will be emitted to standard out. And of course, it's reading CSV files, so you specify a delimiter and a source data file. Okay. Now, this is all I have to do for docopt to properly parse command line arguments. So what it basically does is it constructs a syntax tree. Essentially, it scans this this block here. _doc is a Python magic attribute that returns the documentation section of whatever object is in question. So in this case, doc is the documentation for this module, this file. So it'll be the topmost text block. Functions and methods and classes, I believe, also have a doc attribute. So if you document a function or a method, what have you, then doc will return that. But in this case, we get this block back, and then docopt will take this, it'll parse it, and then it'll apply that parse tree to the actual arguments that you pass in, and it'll reject any usage of your program that is not compliant with at least one usage string. So let's see, let's check it out. Chmod u plus x ffilter dot py, right now. Okay, so I didn't pass any of the required parameters, so docopt just exited and showed me my usage strings, which is excellent. Now, if I actually now it doesn't reject me and show me usage string. Now I'm not doing anything in main, but for example, if I were to say print args, right? There we go, right? So what's cool about that is that within my main now, there are certain checks I just never have to do. So if I want to know what the source file is that my user specified, I can simply say, instead of print args, I can say that, and I'm guaranteed that this array dictionary subscript is valid. I don't have to check to see if args really contains this value. It has to have, because otherwise I never would have gotten to execute my main. So there we go, right? So I love docopt, so I use it all the time. So we've got that. So now we're ready in the position of knowing what we're going to get passed into ffilter, right? So the very first thing is we know we're going to step through our source file. and emit records. Okay, so the first thing we're going to write is a generator. Def record and we're going to say file name delimiter, right? Okay, and we're going to say with open file name read mode as F for line in F yield line. Okay, and then we're going to say for line, or let's say for record in record generator print record. Okay. Of course. Let's see. Senior moment. Let's actually src file equals args. And let's just get the delimiter too. Delim equals args. Okay. Okay, let's get rid of this for now. Okay. So we read the source file, we read the delimiter. Okay. And we say src file okay. So let's do that. There we go. Okay. So we know we can step through our source file and emit records, right? Now, the next thing is that we know we're going to have some logic that computes either a go or no go for each record, right? Is this record compliant? Now we're going to hard code that logic into this utility for now, and then later on we'll abstract it out so that we can refer to it, from outside. So that basically you don't have to change the utility every time you change the acceptance logic. It becomes pluggable and it becomes more of a general purpose utility. Okay, so let's call that function for now pass record. Okay. But actually, before we do that, let's change how the record generator brings up data, because I already know that, so I'm looking at the CSV file, and I know that I want a couple things. I want to address each record in this file as data, right? Ideally as a dictionary, with the keys being the names, of the respective fields. But I know that I also want the actual text line as well, because remember, I'm going to emit essentially a CSV file as the output of this, right? And what I don't want to do is I don't want to kind of reconstitute the original record from that dictionary. There's too much room for error there. I don't want to do that. I just want to make sure that I get each line, and at the end of the thing, we're going to spit out all the actual lines that passed muster. So what I want to do is the following. I'm going to create a named tuple. Let's see, CSV record equals named tuple, and I'm going to call this CSV record, and it's going to have the data and the line. Okay, Okay, that's one. So, and then, so what I'm going to do is I'm going to update record generator, okay, such that when it steps through the source data file, if the file that's passed to it, it's going to return not just one thing, not just the line, but it's going to return a combination of the line as a record, a dictionary, and the actual text line. So I could just return a tuple, right? But named tuples are nicer because they're it's easy to remember kind of what you did with them. So so what I'm gonna do is I'm gonna say with open file name are as, I'm gonna call this CSV source. And I'm going to say, let's see, do we have, oh, I had CSV. So I'm going to import CSV. So Python's got a CSV handling module that's got a lot of useful stuff in it, right? So I'm going to say CSV reader equals CSV.dictionary reader CSV src, right? And then I'm gonna say with open file name r as line source, right? And then next line src. Now what am I doing here? Well, the fact is that, remember, I want to step through this file, and I want to use the dictionary reader will let me step through the file and capture each line as a dictionary, okay? But I want to also capture each line as a line of text. And so I have to open two file pointers onto the same file. That's fine because they're both read-only file pointers, but I can't have these two, my two readers, my two line generators, if you will, I can't have them both use the same file pointer because when one advances, the other will it'll change the underlying state of the file pointer and they'll mess each other up. So it can't do that. So I'm opening two different file pointers onto the same file, and the first thing I do when I open the ordinary handle onto the file is I call next on it. This of course returns a generator, and I'm calling next on that generator, that line generator. Why? Because we're going to stick with one basic assumption as we write this utility, which is that each of our input files will have a header, okay? And of course the header is not the actual data, it's simply the names of the fields. So whereas the Python's CSV dict reader will consume the header and use that to construct the dictionary records, the ordinary file object will not. So I have to manually advance it past the header so that it gives us the right thing. And then what I can say is, so actually once I do that, I should be able to say for record in CSV reader, right? Yield, and then I'm going to say, actually I don't have to do that. I can say CSV record, right? And the data attribute is going to be record, and the line is going to be me calling next on the line source, like that, okay? So that's what's going on there. Clean this up, right? And then let's see. So now what I'm going to do is, well, if I just print the record right now, yeah, let's just run that. And there we go, right? CSV record, right? Data equals the order dictionary, right? And the line is the actual verbatim line. This is exactly what we want, okay? So that's good, right? So now we can step through the source data file and get all the records. Now what's next? we're going to have some logic to pass or reject the record that we pass in. Now, believe it or not, I'm not going to pass a tuple into this. I'm going to pass an actual, the actual structures for reasons I'll make clear later. So I'm going to say data. I'm just going to say data in line. Okay. All right. And I'm going to say delimiter. All right. And leave myself out if I want to start passing some optional parameters later. So let's just say, for now, let's just fail everything. Okay. All right. So let's see. So now, okay. So we're gonna, let's see what we're gonna. Okay. So for each record, we're going to say, if pass record, record dot data record dot line delimiter, and we're going to print is compliant Actually, no, I'm going to do it on the next line. Okay. And else print the record is non actually don't need to do that. Because I'm going to print it out in any case. Okay. Okay. So here we go. All right. For record and generator, we're going to see if it passes. If it does, then we say that it does. If it doesn't, we say it doesn't, and we print out the record. All right. So let's see. Let's get rid of that for the time being. All right. And let's run this thing again. Oops. Let's see. I said delim, didn't I? Okay. So let's see. So we're stepping through and we're failing everything, right? So we expect that. Okay. Now let's add some actual logic to make this actually behave correctly. Okay. So let's take a look at our dirty data. Right. As a matter of fact, let's. I think we should maybe pull it up in another window. Let's say split right. Okay, good. Excellent, right? So here's our dirty data. And again, we have these three records at the bottom. The three first records are fine. The last three, I know I added and purposely introduced errors. So the simplest one to deal with is probably on line 6, right? Here we have this guy, and we know that we're missing a bunch of fields. The actual, I've counted what we have 10 fields in this record. There are 10 fields per record in the canonical format, and this guy's only got 3. So let's say that all of our output fields are mandatory. So if you have If you don't have 10 fields, you're wrong, okay? So let's so we can say, for example, we can say field tokens equal line dot split delimiter if len field tokens not equals 10, 100, 10, all right? Return false, and then otherwise return true, okay? All right, so let's see what that's about. Okay, very good. So we've passed the records that have all the required fields, and we have failed the record that did not. All right, now we're still getting false positives, right, or false passes. This guy's dates are in the wrong format. This guy's email address is in the wrong format. But we're moving along. We at least failed this one here. So let's kind of tighten the restrictions a little bit. So we've got we took care of line 6. Let's take care of the bad dates next, okay? So to do that, we are definitely going to get into some regex, right? So regular expressions, import re. So I know I've talked to some programmers who've been in for a few years, but they really haven't gotten into regular expressions very much. And I urge everyone who has not to do that. What are regular expressions? Regular expressions are expressions written in the regular expression language. What is the regular expression language? It is a very terse and kind of notoriously user hostile, but very, very powerful language for pattern matching in strings. Okay, it is old. I'm not quite sure how old it is, but it dates to some of the earlier days of Unix systems, and it's one of those big pieces of infrastructure that we get for free, being in the Unix ecosystem, Linux, GNU Linux, what have you, GNU Unix, what have you. So Python has a regex module, and we're going to use that. Import re. That's the regular expressions module. So the way it works is that you specify a regular expression string. That is literally a string written in the regular expression language, and then the regular expression parser that's built into your language in your runtime will take that, compile that into essentially a parse tree or what have you, and or compile it into a structure that will then pattern match a string that you throw at it. Okay, so Python has very good string handling, but for some things, regex just makes things a lot quicker and a lot smaller. So we know that we have this date format here, right? We have a couple numbers, and 4 numbers here separated by slashes. Okay, so let's do this. Date regular expression equals re dot compile. Okay, and this signifies that it's a regular expression string, the preceding R. Okay, so we're going to say that we have a character set that is all the characters from 0 to 9, and bear with me on that one, because of course I know that there's no months to begin with 9, but that's all right. and then we're going to say this is a quantifier, okay, and we're going to say that, you know, two numbers, right, and then separated by a slash, and then we have another character set, and then we're going to have 2, right? So essentially this is saying 2 numbers, then a slash, then 2 numbers, then another slash, and then four numbers, okay? Right, so that's, no, there we go, okay. Right, so that's what this means. This is meant to match an input string, to pattern match an input string where you have, that is supposed to have 2 numbers, a slash, 2 numbers, a slash, and 4 numbers. Now, I'm also going to anchor this to the beginning of the string and anchor this to the end, so that I'm not just searching for a compliant date string in the middle of a larger string. I'm saying that the entire thing has to start here and end here. That's essentially what anchor characters do in regex. Okay, so let's see. All right, date rx dot match. Let's give this a shot now. So first of all, let's give a compliant date like 12/0 to 2019. Okay, excellent. Okay, 2019 ABC. That does not match, which is good, right? Good. That doesn't match. Let's see, 12/02 2019. That does not match. 1, 2, 3, 4, 5, 6, 7, 8. Doesn't match. Good. So I think this is good to a first approximation. We'll probably go back and tweak this, but for right now, it looks like it's doing what it needs to do. So now what I'm going to do is I'm going to take this and paste it into our code. So I'm going to say date r regex string equals. Okay, so then what I should be able to say is be able to add another condition here. I want to say date date rx equals re dot compile. Let's compile that regex string, right? And then what I want to say is if actually let's do this. Let's say sign up date equals data get sign up date. Okay, right, because right, that's where the data is actually going to show up now. Update, sorry, data. Okay, so again, this is where having the record as a dictionary is very useful, right? Because I can just call get on it. Now, of course, I can't be guaranteed that there will be a sign up date, even though I'm getting rid of records that don't have all 10 fields. That's not enough of a guarantee for me. So what I'm going to do is I'm going to specify a default value, right? So get, in other words, this is why I'm not using a subscript on data. I'm not just saying square bracket sign up date, right? I'm saying get sign up date and return a blank. Actually, well, here's what happens if I would kind of know this already, but if I call get sign up date on a record that doesn't have one, then what happens is that I'll end up calling date rx match. I'll end up calling match on null, and if that happens, right, I throw an exception. So I don't want to throw an exception. So if I instead default to an empty string, then I end up calling match. The worst that will happen is I will call match against an empty string, and I will not throw an exception. It just won't match, which is fine. Whether the sign up date is missing or in a bad format, either way we want to fail the record. Okay, so sign up date, that, and then exp date is data dot get expiration date, right? And then okay, and now what I can say is I can say if date rx, actually excuse me, if not date rx match sign up date, return false. If not date rx dot match, same thing, return false. Okay. All right. So let's see what we've got. Let's just take another look at our data. Right. So okay. So you know this is going to fail anyway, but we also want we know that we want Tiny Tim to be non-compliant. His date does not work for us. Okay. So let's see what we got. Okay. So, here's what's interesting. We have non-compliant here. We have non-compliant here. So let's see what's going on. Let's make sure. If not date rx match sign up date, right? Let's just make sure we're doing the right thing. Sign up date, expiration date, right? So let's see, if not date rx match, sign up date, return false. And expiration date, return false. Right? So let's see, what are we missing? Non-compliant record. We know this is supposed to be non-compliant. Why is this failing? Because this is not our format. Why is this failing? Let's dig into it, right? Let's see. All right. Okay. Actually, yeah. Paste. Okay. So I think I'm doing something weird here, right? Let's see. Data get sign up date. So actually, here's what we're going to do. We're going to also build in a limit switch. Actually, not right now. What we'll do is we'll simply for now, I'll just process the first record. We'll eventually go back and build in a limit switch. Okay. So let's debug this, because this should do what we want it to do, right? Actually, I can see one issue already that may cause us to reject some records falsely, but certainly the first record in this file should be passing because we have 2 digits and 4. Yeah, so that should definitely be passing. So let's see what's going on. So what we're going to say is, actually, we're going to do a sign up date. Let's just see, right? Print sign up date for this record is sign up date, okay? Print Okay. All right. And now, let's go back and get into some debugging. Okay. So something's wrong there. Why is it not picking that up? Sign update. So there's some kind of, either I've got a typo, let's see, or something. Let's sign up date, expiration date. So let's do this. Let's see, are we, next line, so CSV source. Okay. So let's see what we're doing here. Data. So let's see. Print keys for this record are data.keys. There we go. Okay. There we go. Okay. So I know what the problem is. Let's see. Right. Args delimiter. So let's do this. Oh, actually, I don't need to do that. Now I know what's wrong. What's wrong is that I know exactly what's wrong. What's wrong is that when I created the CSV dict reader, I did not pass the delimiter equals delimiter, right? So there we go. So now when I do that, because actually, excuse me, CSV source, comma, right? Okay. So what it was doing with what the CSV dictionary reader was doing was assuming that the delimiter was a comma, and that made everything cockeyed. So passing it the actual delimiter that I specified at the command line should fix our problem. Let's see. There we go. Okay. So now we're getting all the keys, and we're doing a match. We're getting the dates as we want, and that record is compliant. Excellent. So now let's clean up after ourselves after our debugging expedition. Okay. And move on to the next objective. So we're good to go here. All right. I don't need that. And I don't need that. All right. Okay. Okay. And now, let's see, clean up after. Okay, good. Okay, so now let's run it again. And let's see. Okay, interesting. So we got only one compliant. Oh, no, never mind. I'm breaking after one. Let's get rid of that. Clean up after yourself. Okay, now let's run this. All right. Okay, so Johnny Walker is compliant. That makes sense. This person is Jane Doe is non-compliant on account of date, right? And we'll get into that. I know what the fix is here. This person is also non-compliant. And let's see, and this person is non-compliant. Okay, so there we go. So, and this person, so I think we're failing some dates that we should be passing because, okay, technically, you should use two numbers, but we can figure that. We know what this date is, right? So we can figure this out. We're going to tweak our regex to fix this, okay? And here now, let me just clear so it's at the top of the screen. Just okay, right? So here we're passing a record that should fail, but its dates are compliant, but its email address is not. So let's fix the date thing first. I really want this, I know that our first three records are compliant, so I don't want to fail things that we should be passing. So let's fix that first, okay? Again, what's the problem? The problem is that for some records, we may only have a single digit specified for the month as opposed to like a 01, for example, for January. But that's fine. That's no big deal to us. So let's tweak the regex. All we have to do is to say that the month, see, so again, this is a character set, right? And any of the characters in this set must appear 2 times, right? However, the number in the quantifier brackets. But if we say 1, 2, right? And if we say 1, 2, then any number can appear once or twice, and it will be valid. It should pattern match. Let's see if that works. All right, clear that. Oops, is that a caps lock? There we go. Okay, and okay, very good. So now we are passing all the records that we should pass. Okay, and we're failing 2 of the records that we should fail. We know why we're failing this guy because he's missing a bunch of fields, and we know why we're failing this guy on account of date. Now the other problem we have is that we are passing a record here that we should fail. This person's email address is not in the canonical format. Of course, at and dot, we could very easily kind of discern the correct email address from this. But for our purposes, we're going to say that unless you're in the canonical email format, you will fail, right? So let's add that criterion, okay? Now for this, and the email addresses are notoriously tricky in terms of pattern matching. So, when I knew I was going to do the side quest, I already went and Googled an email matching regex. And so I'm just going to go to my page and I'm going to paste it right in here because regex string and R, and then we're going to paste paste it right there. Okay, now this may not, just looking it over, I can see that this probably gets us, is probably a good first approximation. I'm going to go ahead and anchor this regex to the top of the string and to the bottom, so that we're matching front to back explicitly, and that's it. Now, again, these things. In a production system, I'd want to run a lot more tests on this to verify that we're not failing email addresses we should be passing, things like that. But again, good enough for a first approximation. What we're really trying to demonstrate is the fact that we can kind of inject logic into this process and build a more robust pipeline using tooling that we write. Okay, so here's our email regex, right? So now let's just say email regex string rather. So now we'll actually create the expression. I want to do this. Hold on a second. Okay, good. And now I want to say email rx equals re.compile email regex string, right? And then I want to say if not email rx dot match. So of course we have to get the email. So we say email equals data dot get, and we're gonna say, get the cursor right away, email address, comma, there we go. Okay, so we'll get a blank if it's not specified. Email address. Okay, so now email, right? If we don't get a match on that regular expression, then return false. Okay. All right, so let's see what we got. Right? Clear. All right. Okay, that's kind of all right, right? The first 3 records are compliant. We know they are because we've been working with them, right? And they are fit for purpose, right? And the last 3 records are all non-compliant, right? And again, this one's non-compliant on account of email, but it doesn't matter. Now we could get more sophisticated and have like, return kind of status messages that say, maybe that have an error, so why things fail. But that's not, that's outside the scope of this side quest, right? We're just trying to filter out kind of obviously bad records that are going to break our pipeline, okay? So that's good. Now let's start to clean up after ourselves and get ready to kind of bed this in as an integral part of our pipeline, right? So remember that we are ultimately going to want to do what? We're ultimately going to want to either generate a new CSV file or emit records to standard out. But either way, our output, put it this way, the good records that we output have to be immediately readable by another utility, for example, xfile, because remember, we're using xfile to read CSV files. We can also use xfile to read data directly from standard in, but either way, we have to make sure that we take in a proper CSV file, reject the bad records, we output a proper CSV file or a set of CSV records. So the first thing we'll have to do, given the fact, well, let's clean up after ourselves first. Let's get rid of spurious comments, right? Okay, so let's say this. We have one of 2 modes we can be in. So let's tackle that first. We know that we can be in accept to file mode or reject to file mode. So let's just write our mode strings here. Accept to file mode. Actually, what I'm going to call this is accept -to file. Okay. Actually, what I'm going to do is I'm going to, for reasons which I'll make clear later, I'm doing this. Okay. Reject to file. Okay. Ultimately, ultimately, it doesn't matter right now what the actual content of these strings are, just so long as they're different. Okay. Okay. Now I'm going to say if args well, actually, I could say, yeah, accept to file mode. Mode equals none. There we go. Mode equals accept to file mode. If args reject to file mode, mode equals reject to file mode, right? I'm saying print, print running ffilter in, in mode. Okay. Okay, so let's just see what we've got. There, okay, run that. Okay, running an accept to file mode, wonderful. And if we say reject to file, good, okay. So we know we can capture the mode switch correctly. Great. Now, so what we're going to say is this. If mode equals accept to file mode. Okay, let's do that first. Actually, let's yeah, it's fine. Doesn't matter which one we do first. Okay. Okay, so if we're running in accept to file, then what it means is that the good records get written to a file and the bad records go to standard out. Okay, so let's do, we can also do, with open target file name, as f. Okay, so we're going to open the target file in append mode for now. I suspect I might want to tweak that a little bit, but it's fine for now. Okay, so and what's our target file name? Well, what are we passing as a, so it's just file name, right? So let's just make sure we capture that. So let's see. Target file name equals args file name, right? Okay, so now we're going to open that file in append mode for now, so we don't accidentally overwrite anything. Okay, and we're going to say if mode is accept to file, then what we're going to do is step through the source, right, for record and record generator, and if the record passes, we're going to print record dot line. Okay. Okay, so because I'm very sorry, accept to file. So if the record passes, I'm very sorry. So we're going to say f dot write record line. Okay, and then if pass record, and then if it fails, print record dot line. Okay. Okay. So let's just go over that, right? If we are running in accept to file mode, that means good records get written to our target file. So step through the source, and if the record passes, if it's good, write it to the file. That's right. Accept to file. Okay. And then we say if mode equals reject to file mode, okay, then for record in record generator, same thing, src file delimiter, right? If pass, actually we could just say if not, no, just the same. If pass record dot data record dot line delim. Okay. So if the rejects are going to the file, then that means we're printing record line. Okay. And then else f write record line. Okay. So If the rejects are going to the file, then everything that passes will go to standard out, and then, right, and then the stuff that doesn't pass will go to the file. That makes sense to me, okay? Okay, so let's, okay, so let's say reject to file. That's the first one, right? So we're going to say, so what we hope to see is 3 clean records emitted to standard out, right? Yes, excellent. Okay, so 3 clean records emitted to standard out. Let me just foo.txt. Let's do that again. Okay, more foo.txt, and there we go. Right. So our 3 bad records, our 3 rejects were printed to the file, and our 3 good records were printed to standard out, and that's what we want. And then if we do the opposite, right, if we say clear, and now we want to run an accept to file, right, accept to file, okay, and then it's okay, then boom, then our rejects, okay, are printed. And if we say cat hellonet.txt, then we see that our good records go to the file. So this makes sense. Now, a couple more cleanup things, right? We notice that we're generating we're generating some extra characters, some extra new lines here. So let's fix that. We're always saying record.line.strip, print record.line.strip. That should fix that. Okay. Let's see. Right? So accept to file. There we go. That's better, right? So instead of skipping lines, we're right. And if we say reject to file, same thing. Okay, good. So tighten that up. Okay. And what's missing? Well, I can tell you, reject to file. Looking at this, I can see that we're going to have a problem when it comes time to feed the output of this to something else. Why? Because, well, first of all, we don't want to print this. We don't want to print that to standard out anyway. The reason is that remember we have to output a CSV file, right? So we could just as easily say, like with this here, let's say we reject a file, right? And so we are only emitting the clean records. So if we decide to, my file dot CSV, right? Okay, so more my file dot CSV. Well, we've got all our records, but where's our header? Right? There is no header, and that's a problem because remember that xfile, for example, reads a CSV file and expects to see a header. That's how it knows what the field names are. So if we're emitting these records and there's no header, it's a problem. So let's fix that now. Let's just do def read file header, okay, and file name. Okay. Now we shouldn't need the delimiter for that because we're not. We don't really care what the delimiter is. We just need to make sure that it that we spit out that line at the end. So we'll say with open file name in read mode as f, return f dot read line. Okay. Okay. All right. Let's just see. Let's see what we've got. We say print well, let's just do, you know, HDR equals read file header src file, right? And print source file header is that HDR, okay? Just to see where we're at, okay? Clear that. Wait. Oh, silly. There we go, okay? That's perfect, except that we've got an extra new line, so let's get rid of that. Okay, that's all. Okay, good. All right, so now what we should do, right, is that because we have that header, we're now going to say with open target file name. So we open the target file, and really, actually, the first thing we'll do is, yeah, when we open the target file, we're going to print the header and we're going to f.write header. Okay. All right, let's see if that's more or less what you should be doing, right? Okay, so the regex go to a file, and what we have now is an actual CSV file with the header, right? If we go back and we say myfile.csv, oops, excuse me. Geez, learn to type. myfile.csv, right? So that's what we want. That's a full-fledged CSV file. It's got the header and it's clean, right? We've got our first 3 records, you know, John, Jane, and Tom. Okay. So this is just about a good stopping point. I've been going for a while, but the last thing I want to do is make sure that this is readable, that we can plug this into xfile, right? So let's just run this one more time. Okay, now I say this is a stopping point. You know, don't think that we won't revisit this this utility, because we certainly will. There's there's more cleanup we can do, and I also want to go over some of the things that I kind of blew through the first time and didn't really explain. Because I was just trying to get this up, but definitely I'm going to go through and kind of you know, justify some of the decisions I made. Why did you do things like this? What have you? So that there's kind of interesting subject matter just to dig down into, even with a utility as trivial as this. But hopefully you got a chance to see how I think about code, and you know, in general, my philosophy, which definitely is tied up with the Unix philosophy, right? Building small, sharp tools, and also like doing very small scale experiments, right? Like this is a very tiny utility, but now it's doing a piece of useful work for us. And now we can use that Unix infrastructure to connect it together with something else and start to build on that. So this kind of thing is a lot of fun for me. And hopefully it's interesting and or amusing to you. So again, let's just do this one more time. Okay. So reject a file. All right, good. So let's let's tie this together with xfile, right? If we do that. All right, so that's gonna give us a CSV file. So now what we should be able to do is just to use the pipe character. And then say xfile, right? Let's break this line, right? So we're going to pipe it to the xfile command, but I want to break this line and have it be the same command. So we'll use the backslash, right? And then we'll say xfile, right? -- config. What is it? Extract test 3.yaml -- delimiter pipe and -- map. It should be test, okay? And then what I want to do is, so again, let's review right quickly. We are running ffilter. Ffilter is returning. It's churning out an actual CSV document to standard out, but we're going to now send the output of ffilter, send this same output to xfile. We're piping it to xfile, and xfile is going to read our config file and run run this map against the input data. But xfile is not reading from a file; it's reading from standard in. So we should be able to say -s. Let's give it a shot. And there we go, right? So now we have the beginnings of a real pipeline. We're literally pipelining data from the output of our filter, okay, to the input of our transformer. And that's cool. And now this same file that crashed xfile when we ran it just directly against xfile, now we can just deal with it, get rid of the bad records, and now we've got something that works. So this is where I'm going to stop for this video. I'll put the relevant links in the description. Please like and subscribe if you thought that this was something worthwhile, and we'll pick it up again next time in the engine room. Thanks for watching, and take care.